Hello, everyone, and welcome to a new episode of the Kiln Restaking Rendez-Vous. I'm Edgar Roth, protocol specialist at Kiln, the leading enterprise-grade staking platform. And today we have Deli, who's co-founder at Automata, and we're going to be talking about the Automata AVS. Deli, how are you doing today?
Hey everyone. Yeah, hey Edgar. This is Deli. Yeah, glad to be here. I'm good.
Great. So to start this off, we would love to have if you just introduce yourself, what led you to work in Automata and what led you more broadly to working in the wonderful crypto space.
Sure. Yeah. I actually started learning programming in high school. I was doing a lot of coding competitions. The first programming language I learned was Pascal. I'm not sure if everyone knows that. Then C, C++, then eventually Rust, because many blockchain projects are using Rust right now. So I also studied computer science at my university. And then also I learned how some of the component works in the computing space, like how CPU works, how operating system works, and how compiler works. Then after that, I moved to Singapore, doing my research at National University of Singapore, trying to learn what is the system security and network security. That's actually the moment I started learning about Bitcoin. I read about this white paper, and also Ethereum as well. At that time, people call it word computers. I learned what is Solidity and how it works. So that's basically started the chapter for me, and later on I joined a blockchain company called Zilliqa. Spent some time there as core developers and also as head of infra, trying to take care of thousands of nodes running across different clouds. And then eventually I started Automata and then doing started our story basically. Yeah.
Great. Well, it's a perfect segue into my next question, which is what is the origin story of Automata? Because you guys have been around for quite some time, and you've been doing a lot of things. I saw yesterday a presentation of you talking about MEV minimization. So yeah, I would love to have the background story and what are the different projects that Automata worked on and what led you to work on what you're doing today.
Right. I think I will start with the name itself. So because both co-founders were comes from the computer science background. So I mean, we choose this name is because it carries a lot of meanings in the computer theory, because it essentially means kind of a abstract self-acting machine that just execute a bunch of sequences deterministically. So it's a very good representation of what blockchain is doing. So if you imagine that blockchain, what blockchain does is it takes input, it takes state transition, instructions, and then execute those things and eventually generate the output on chain. And each of the blockchain node, part of the consensus protocol, they're basically following the protocol and trying to reach consensus at the end of the computation. And even in today's context, when people are talking about off-chain computing, it's or coprocessor is also a type of automata, because it runs computations off-chain, but it's deterministically executed, and the result will be later committed back to blockchain so that everyone can verify it. So we actually started Automata with a focus on building middlewares using TEE, or trusted execution environment. So the reason we use that is back in the time that we're doing research in lab, we found out that this is a much more efficient way or practical ways to improve the security in computing systems in general. We've been doing some research on securing some of the networks, securing some of the systems, but we haven't really spent time on doing this with blockchain. So that essentially made us wondering that what we can do with DE in blockchain. And then at the very beginning of the project, I think we started looking at the MEV issue. we kind of use TE to create a fair ordering mechanism so that all the swaps that goes to a particular DEX can be ordered just in a fair manner. So at that time, we're thinking about maybe just do FIFO, like first in, first out, this kind of ordering based on the time that the transactions were seen by the node, basically. So that was kind of the beginning story, and it really helped us to get tractions and get the fundings as well. Then moving on, we explored other spaces like how we can secure privacy for governance. We also like look back into MVB space when the story was switched from like POS networks to a proof of work network to a proof of stake networks, like when Ethereum made the transition. Eventually, we started like thinking about how we can use TE to provide like more general computing. And I mean, coprocessor was a really good start. I mean, earlier last year we started looking at that. We figured out there's multiple ways to achieve the security using coprocessors. We had one of the product like kicked off at that time. It's called WirePC. It's actually running entirely in TE, using its coprocessor capability to process all the requests coming from users. We make sure that all the private information, all the metadata information is stripped out from the request, and eventually the providers will not just see will not get to see the user privacy, basically. So then earlier this year, I actually started from like late last year, we learned about EigenLayer. We started like thinking about what we can do with AVS. And also at the same time, we be in contact with some of the rollups who are interested in multi-prover. Like multi-prover is essentially also a form of coprocessors that we're doing, trying to secure some of the compute that's running in rollups. So that's basically the entire journey, like right from the beginning to today. Yeah.
Great. Very interesting. So yeah, lots of things, but you were always very, very involved in using TE as a solutions to the problems that you were finding. Like we could say, I guess. That's really interesting. And yeah, can you talk a bit about like what's the Automata AVS today, and what is that is try to solve, and basically like what are going to be the users of this AVS?
Yeah. So I mean the AVS we just launched is called like multi-prover AVS. It essentially carries out all kinds of multi-proving tasks that we think would be useful for some of the customers. So we're thinking about like helping ZK rollups as well as ZK coprocessors to mitigate some of the issues that could appear in their circuits. I mean, if you look at the way that ZK VM or ZK circuit-based project work, it relies on correct implementations in those circuits, as well as the verification logic that running on chain. But chances are there will always be a bug in the circuit. I mean, we've seen that in the past in some of the projects. And good news is all those issues were like detected very early on by either by developers or by auditors, or even by white hat hackers. But then the reality is, moving on, there might be more that goes undetected. So we really need a security mechanism that can help the rollups or help the key circuits to detect the issue. So the solution we have is based on a concept called multi-prover, which was just coined by a term coined by Vitalik. I mean, in 2022. So the mechanism of multi-prover is essentially trying to check the same computations from like different provers or different implementations of provers. So that's why we have the multiple like different implementations here. So we're taking the canonical implementations from the rollups as the primary ones, but in the meantime, we're creating a parallel independent implementations that's running in TE. And even in that category, there might be like many different flavors of TE that we can use. So currently we have Intel SGX based ones, but moving on there will be AWS Nitro Enclaves, as well as like some new TEs. For example, Intel TDX. People have been exploring the implementations here as well. So I mean, with all these kind of diversified implementations, it's really difficult to miss a bug, because like unless like all of the implementations have flaws, and the attackers would be able to like know them, and also like trying to exploit at the same time. Otherwise, it's essentially like harden the entire system with like enough security, and that's what we're doing with Rollups. And then the reason we bring this up to AVS, to make it into AVS, is it helps us to kind of gather a group of nodes, a group of operators that has enough diversity. I mean, of course, it will have different geolocations, deployment. Some of them will run on cloud, some of them will use their bare metal machines. And like in terms of the TE flavors, maybe some of them has expertise in operating a particular type, while the others have other like preferences. I mean, this is kind of a great way for us to like further decentralize the network and try to like enhance the security.
Great. You mentioned previously ZK Rollups. Could you just remind our audience like what are ZK Rollups, how they differ from optimistic rollups, for example, and maybe give an example of how a ZK Rollup could use Automata's multi-prover AVS?
Sure. I mean, I think I will start from the rollup story first. I mean, rollup is a mechanism to essentially scale the computations that were supposed to be done on Ethereum, but now like it will be done at the kind of layer 2 word kind of. So what like goes back to ZK Sync. So the scaling approach it takes is relying on a kind of the ZK proof system. So because we found out that like if you use some of the ZK proof system, you are able to achieve you can call it compression or scaling effect, so that massive computation that's done on layer 1 or other places natively can be actually compressed and eventually become a very small footprint computations on layer 2, where you can just verify the proof of the like the execution. And the entire system was relying on like some of the like leaky schemes out there. Many rollups may use like different type of leaky system, but the high level workflow are similar. So essentially, the prover will take batch transactions on layer 2, those layer 2 blocks, put it into the circuits. I mean, the circuit has to be kind of designed and also implemented beforehand. So the prover will take the input and try to generate like a small footprint like computation with just enough data that can be like executed on layer 1 to verify. So once it's verified, the transactions that was included in the batch were considered finalized. And the difference between ZK-based rollup to optimistic rollup is the mechanism is so different, because like in ZK rollup you can just rely on you can just trust the execution. Like if, for example, of course, if the circuit is implemented correctly, but then in optimistic rollups you are relying on a optimistic mechanism. So you so the sequencer will be putting a bound in the transactions, and later on, if the transactions are found to be faulty, there will be a challenging period going on. Then so the transactions can be kind of rectified. I mean, the wrong state can be rectified, and eventually people will be happy about the final correct state. So this is like essentially all the rollups that out there. What we do with ZK rollup to do the multi-prover is we're trying to actually run same kind of repeated computations on all the batches that's submitted by the prover, like by L2 sequencer node or prover node. So what we do is we take the transactions from either L2 full node or waiting for the signal that those bad transaction has been submitted on layer 1. Once our provers see those kind of blocks or transactions, we'll be taking that, putting it into the TE prover that we implemented, but hosted by other operators. Eventually, the execution will be done like by all the operators or by some subset of them. We will take the result and throw back the result to layer 1, so that now at layer 1, at the root contract for the rollup, you will get to see like at least 2 proofs. One is coming from the key provers. The other one is coming from our TE prover. So then I mean the layer 1, I mean the rollup contract can just make a decision on how to like deal with these 2 like proof result. Of course, they can just it can be a different, really different play out there. They can trust the primary one as like, for example, the decay proof, or just like treat the TE proof as a secondary kind of implementations. So if something different was happened like between these 2, then something is wrong. Maybe something is wrong either in the ZT implementations or in the TE implementations. And that's actually the time that people should be alarmed and trying to like figure out like what should be the next step for the rollups. So of course there will be other ways to do this. There will be many different combinations or mix of like TE proof and decay proof, but that's something we'll be like keep exploring with other rollups.
Great. And my follow-up question is around like the economic security that is provided by EigenLayer. How do you plan to use this economic security? What are like the basically like I guess my very basic question is like, when does stashing happens?
Yeah, I mean, I think our view of like economic security out there is it's really helpful because in our design, in this kind of DE-based computations, there's actually a lot of things that has been kind of hardened, guaranteed by using the hardware. For example, it's very difficult to see a node that goes in a different way, because all the code, all the data that goes to those DEs is kind of guaranteed by the hardware, because like it's not possible for those operators to alter the implementations or trying to inject some like outside data or inject some of the like implementations into it. But then is there still a risk of like liveness issues? I mean, because those operators are still the ones that physically possess all the hardwares. They could just power it off or restart it, or even like disconnect the network goes to the like all the TE nodes. So the economic security here would is well positioned to help us to ensure that those nodes operators will try their best to ensure the uptime of the TE provers, TE nodes. So that's exactly what we need. And in terms of the slashing, I mean, because of the some of the kind of objective claims that we can have from TE, the slashing will be very much clear. Like if certain nodes like indeed does something wrong, we will know, and actually everyone will know, because there will be it will be a public record that can be checked like on chain. Everybody will know that maybe a particular node indeed submit something wrong, or like if the liveness condition is not met, we will be also like knowing that as well, because like it's clear that certain node didn't submit like enough work. From there, we can just treat it as a kind of a slashable condition. So I mean, basically, all those situations out there will be kind of objective. We can just do the slashing based on the kind of the gathering of the result, and then ensure that everyone is and I mean the faulty ones is slashed like correctly.
Gotcha. It's interesting that you said that most of the faults would be objective, because we recently introduced to the concept of intersubjective faults, And this is just wanted to ask like a question: if you think that you will still have, for example, the need to use eigen security for intersubjective faults.
Yeah, actually, because like just like I said, there's always a type of faults or like misbehaviors that we couldn't really attribute properly, like using some kind of proofs or using some kind of evidence. Liveness is one of them. Other things might include like some of the occlusions that could be done by some of the operators. I mean, it really goes undetected. But like if there's enough kind of consensus or understandings between like the global view, on the global view of the what each of the operators doing, so it might be possible to be detected, and in that case we might need like the intersubjective like eigen token to deal with it. Maybe we will go for some kind of forkings or like just kick off the like the mechanism to make sure that the bad behavior will be punished.
Gotcha. And do you already have like I would say like an idea of like the amount of security, of economic security you would need like per dollar at stake?
I think a good measurement of the security that we might need is based on the assets or the value that we secure. So right now we're trying to secure the rollups using the multi-program mechanism. So that's really a good reference. For example, some of the rollup that we support is already reaching like 100 millions of TV out over there. So I think that would be a really good start point for us as well. But of course, because we are because the like if multi-program goes wrong, what is effect is essentially it might not like slash the or punish the bad actors enough. So we probably don't need like exact amount of the TVL to be the kind of security boundary. It can be a certain percentage less. For example, we probably just need to get like 20% or even 50% of the like the chain's TVL. So this is some factor that we're trying to measure and also consider right now.
Gotcha. Yeah, just last question on economic security. Have you already had some reasoning around like a preference towards like pooled security or attributed security, or is it something that you're not like necessarily a concern about?
I think as of now, we will just, we all start from the shared security, the pool security that Eigen already provide. We also still just learn about like more about the attributable security that they're offering. It's probably a good mechanism for us to just like further increase or have a mechanism for us to work with each of the like individual project out there, because this provides some preference that we can, or different ways that we can do with those partners. Like I saw that just the discussions are like about this. They think that this is a insurance mechanism, which is also interesting because like if you're using a TV systems, like if people are really confident about their setup, about their operating like experience, it's possible that we can even enter this kind of like interest like scheme, so that like if things are correct, they will be rewarded properly. But like if things goes wrong, like those the slashed like matter will be kind of redistributed to the victims.
Gotcha. Just want to talk a bit about your general timeline. So first and foremost, like congrats on launching your AVS on mainnet, and Kiln is really happy to be supporting your AVS. Wanted to know if there were if you could share like what's next for Automata's roadmap. I heard that Squirrel will be the first team you'll be working with. Could you share maybe like what's next for 2024 in terms of partnership work with other rollups?
Yeah, I mean, as of now, it's quite clear that we're working with Scroll and Linear. We help them to develop like the multi-prover system as well as each of the individual implementations for multi-prover. And the next step for us after launching AVS is really kind of complete the entire system, because like if you look at the multi-prover system, it has so many components. And so far we had the implementations of multi-prover. We had the AVS acting as a kind of control plane to organize all the nodes and try to facilitate the tasks, and as well as the payment for the execution as well. But then there's still some like missing part out there, because for TE we have to do the attestation properly. It's also a fundamental mechanism for us to know that each of the node running out there can be trusted. So I think it's quite clear that the next step for us is to have a attestation layer either running as a rollup, or we'll be using some latent mechanism to try to scale it up so that we can run the verifications for the attestations much more efficiently on chain, and then all those evidence of attestation will be used as a mechanism to show that if some operators are really following the protocol. So so we're probably gonna have a rollup going on as a attestation layer, so that we can gather all the attestations there. That's probably gonna come out really soon. As for the other multi-prover integrations, or in general the co-processing integrations, we'll be working with some of the KVM projects, trying to also like in a similar manner, trying to secure like the computations down in the ZK circuit. And also we're actively looking at the some of the AI computing space. We know that there has been discussions going on about confidential AI, which also uses like this kind of TE mechanism. There will be like GPUs that's capable of doing like attestations, doing like confidential compute. So that's also something we might consider.
Amazing. Sounds like there's going to be a lot of potential use case for this AVS. So great stuff. My follow-up question is around the revenue model basically for the AVS. As you know, like this podcast is really for an audience of risk takers, and the number one question that our risk taker ask us is how much yield am I going to get on EigenLayer. And so to understand that yield, it's really important to talk to the AVS team. So my question to you is basically like, how are you going to incentivize economic security to secure your AVS?
Right. I think ultimately what we want to ensure that we will be having enough operator nodes running all kinds of TE implementations, and trying to like collectively protect or support some of the partners or some of the like AVS customers that uses the services. So the incentives for the operators, for the operation, as well as for the risk takers who help with the post security, we of course coming from like our token itself. So we'll be allocating enough amount of the token as the like early stage incentive to bootstrap the network, to ensure that like all the operators and stakers were like treated with like enough rewards. And of course, because like we're directly working with some of the rollups, I mean we're trying to see if there's any possibility of like rollup allocating a certain amount of tokens as also a security budget, because we are creating a security system for the rollups, and this helps with like enhance the overall security of the rollup. So it's kind of reasonable. I mean, we can literally go through some of the governance mechanism to maybe just get a grant or get a allocation going on for the operators, and then and of course for the risk takers as well. So this is really something we'll be exploring in the next step.
So we just talked about the revenue aspect of the AVS. Now let's talk a bit about the costs. Um, and it's a question especially coming from Kiln, an operator, is how heavy will the AVS become, especially when it starts basically like working on all of these multi-prover tasks. And can you talk a bit also about like if you have an active set requirement and if that active set will evolve, or if you're really aiming to be like completely permissionless in the future?
Mhm. Yeah, I mean, the short answer to your first question is it's actually considered very lightweight because the requirement of like participating in the multi-prover test is you literally just need to have a TE capable hardware, and that's already generally available across like different clouds, or even you could just build up your own machines using like some of the bare metal components. So I would say like compared to like running a ZK computation, like running things in TE is actually much cheaper, and it's fairly easy for us to build this kind of software that does the task as well. So then to answer your second question, the future strategy for the admission of the new operator node, we do want to like fully decentralize and make it permissionless. Like as long as we have like in the future has enough multi-proof tasks to do. But right now we really have to like coordinate it like between like the operator nodes as well as the workload that we've seen. But but technically speaking, it's possible to become a fully permissionless setup, because like all those tasks can really be just automated, like based on the events that's happening on layer one. So we'll be so those batch transactions submitted by all the rollup nodes could be just like treated as a signal to like start this kind of multi-prover task. And in the future, the operators could just like work together. Like if each of them like individually see this kind of events happening, they will be just doing the multi-proving task and eventually submit it out either to our aggregator or just to on-chain.
Great. Let's close this off by talking a bit about like the broader restaking market. I would love to have like your vision as a builder, as someone that basically like was able to migrate basically what you were doing to EigenLayer. What is basically like your vision for the next 18 months on EigenLayer? What do you think we will see in terms of exhaustive applications being built on top of EigenLayer? And yeah, give us a bit your impressions on that piece.
Yeah, I think actually since our launch on the EigenLayer for the AVS, we also get a lot of questions from some fellow founders and friends, like asking about like what could be done using AVS on EigenLayer. My answer to that is always like you can literally build anything on top of it, because after like understanding what the SDK is offering, understanding what the core contract that Eigen is offering, there's actually not many restrictions out there, like as to like what you can build. You could like build oracles, you could build like kind of coprocessors. You could also like maybe embed some kind of protocols into like AVS, because essentially what it offers to you is just a bunch of operators with like enough economic security. And on top of that, you could just find different ways to interface your protocols with some of the kind of the elements out there, or primitives out there. For example, you could model like properly between your protocol with some of the operators out there, or you could just model some of like the security parameters with like, you know, I mean, interface of security parameters with like economic security that you can get like overall from the AVS or from like each of the operators. So there's just like too many like possibilities out there. And also what I foresee is we might really need like more builders in the space to just like create different AVSs and then collectively enjoy the full security from EigenLayer. because there's really a very high like security guarantee out there. It should be shared with like more and more AVSs. And what was the second question? I think there's also a follow-up just right before the first one.
Yeah, no, I think you answered all of the questions. I guess like I also asked you like what you thought would evolve in EigenLayer in the past 18 months. So like as operators and risk takers, we and probably also AVSs, we are expecting slashing to come on testnet and mainnet, to start seeing also rewards and understand like how all of these will be treated. I'm probably confident that you don't have like much more information on that than us operators do, but I think that's definitely something that will help all of the ecosystem better understand the risk rewards of engaging in restaking.
Yeah, that's true. Actually, I mean, payment and slashing is it's not an easy task. I mean, we have to do it properly when it touches like someone's money, right? No matter it's like the rewards coming from us to those risk takers and operators, or it's money that the risk takers has staked into the system. I mean, it's always tricky to divide properly in the first place. So I mean, we really have to do a lot of experiments, do a lot of analysis to make sure that it's divided securely. Yeah.
Great. And for my just closing question, I wanted to talk a bit about like the competitors to EigenLayer, and not just the competitors on Ethereum, but also competitors using re-hypothecating other types of economic security. What do you think about like the competitor landscape for EigenLayer? Do you think it's a winner takes all market? Do you think there is room for competition? From a builder's perspective, like how do you see the different trade-offs that are being made by different risk-taking hubs?
Right. I think I'm also seeing some discussion out there, seeing like some new project trying to do restaking or becoming a new hub. I mean, the competition is definitely something really healthy to have. I mean, in this space, because if you make sure that each of the party out there doing their best to offer the tech as well as the other like economic mechanism. As for the trade-offs, I'm still trying to learn like what other protocols, I mean other restaking protocols are trying to do out there. I do notice a difference, like some of the restaking protocols are willing to like allow any kind of ERC20 tokens to be the kind of the bond or the stakes. And I'm also trying to understand what's going to be the implication of that, because like not all the assets could be as safe as ETH as the kind of the staking assets. But that's also create possibilities out there. So there might be I mean, for some of the risk takers or users, they could have a preference on certain like high risk profile I mean assets. So that might be like something that they really want. So yeah, I mean, in general, just trying to also learn what's going to happen in the next year.
Great. Well, thank you so much for this discussion, Deli. I'll leave just the opportunity to share anything you wanted to if you had just any last words, and maybe you can share like how people can learn more about Automata, maybe follow you on Twitter.
Right. I think, yeah, definitely just give me a follow on Twitter. My handle is just Deli Gong. And then, I mean, to all the rollout and ZK processors users out there, if like you have, you need this kind of multi-proving system, just talk to us. We're able to also help you to like design the mechanism, also like provide like alternative implementations running in DE, and eventually like just like connect it to the AVS so that like we can have all the operators out there helping you guys on the security.
Perfect. Well, Deli, thank you so much for this conversation. It was surely great. And to the audience, we'll see you guys in the next one. Bye, everyone.